So okay, we will start with chapter 7, part 1. Okay, energy analysis of a closed system. Okay, so tadi kita tengok energy analysis in general. So ada open system, ada closed system, ada stationary system. So for chapter 7 we will see particularly on the closed system. Okay, hanya closed system. So we will cover the part 1. Okay, so starting ni something we already discussed earlier in chapter 6 part 2. So the first law of thermodynamics is an expression of conservation of energy principle. So energy can cross the boundary of a closed system. So closed system dia cuma ada dua, heat and also work. So no mass. Okay, so the temperature difference, so keyword. So kalau ada temperature difference, meaning is a heat. So if you are lifting a weight or there's a movement from one place to another place, so I consider that as a work. Okay, so there's two things. Okay, so closed system first law. Okay, all are related to first law of thermodynamics. Okay, so closed system moving in a relative plane. So closed system moving in a relative plane. So Z adalah elevation, so meaning ketinggian, and V is the velocity. Okay, so first law for closed system is E in minus E out is equals to changes in the energy of the system. So yang ni semua you dah pandai dah. Okay, so energy added dengan energy leaving, so plus dengan minus, I think kita dah tengok tadi, so we already seen. So the final Q net minus W net equals to changes in the system. Okay, so the total energy is actually combination of three things. So dekat sini total energy of the system, so combination of internal energy U, kinetic energy KE, and also potential energy PE. So ada tiga benda dalam ni. So it's more like a summary lah. Okay. So what are the important stuff? So changes in the stored energy. So ini adalah total energy. So changes in the stored energy adalah formula ni. Depan ni ada triangle. So there's a triangle, meaning changes in energy. Okay, ini adalah formula dia lah. Okay, so changes in internal energy, so M U2 minus U1. So U2 and U1 you can get from the thermodynamic table. So ada satu table yang dipanggil as thermodynamic table, so you get it from there. Okay, so nanti saya akan tunjuklah contoh thermodynamic table. So this thermodynamic table is actually in the previous syllabus. So previous syllabus we have one particular chapter just covering on how to get information from thermodynamic table. Tapi kita dah align with the degree syllabus because we want to try get for you credit transfer. Okay, and good news for you. So if you lulus subject ni with at least C, you can credit transfer for your degree. So dekat degree you tak perlu ambil chapter subject ni, thermodynamic. Okay, so baru approved last week. Okay, so because 80% of the syllabus of this subject is similar dengan apa yang you akan belajar dalam degree. So kalau you lulus with at least C, so in degree you don't need to take this subject. Okay, so please do well. Okay, jangan just target C, so target more than that. Okay, so because subject ni I think last year almost 30 people get A, walaupun it's a killer subject. Okay, so you just need to know how to do stuff. Okay, so changes in kinetic energy is half mv square. Okay, so V is V2 square minus V1 square, and changes in potential energy mgz. So mg z is the height, z2 minus z1. So if you see here, it must have for changes. Okay, if not you cannot calculate the change total energy. Okay, so now the conservation of energy principle. So ini adalah this is from the previous equation. So this equation. Okay, so you are getting this. Okay, and if the system does not move with the velocity of or non-flow process, ini KE dengan PE akan jadi kosong because we consider it as a stationary system. Okay, and close for a cycle, so Q net equals to W net. So this is from chapter 6. Okay, it's just a revision. Okay, for chapter 7 we will move with another thing we call as a moving boundary work. Okay, so work are divided into two. Okay, previously kita hanya belajar as work, tapi dalam closed system ada dua work. One is boundary work, okay, and one more is other work. So kalau you tengok dekat sini, what is boundary work? So I just give you the definition. Okay, so ada kat mana? Okay, so boundary work is done by ini steam lah, because of this system. So boundary work is done on this. Okay, so how to summarize this? Okay, boundary work occurs because the mass of the substance contained within the system boundary causes a force, the pressure times the surface area to act on the boundary surface and make it move. Meaning, so if the boundary of the system become bigger, okay, so sekarang boundary adalah yang warna pink ni. So if the piston move and the boundary expand or decrease, so meaning the boundary work is done on the system. So that is what we call as boundary, and boundary work boundary work done kita selalunya panggil WB. So kalau ada B kecil ni, so we know that is a boundary work. Okay, and the formula is pressure, integration of from 1 to 2 pressure with in according to the volume. Kita akan tengok nantilah yang ni. Okay, so yang ni pun I think not so important, but this situation, this statement, quasi equilibrium. I think before this kita pernah belajar quasi equilibrium, so meaning is almost equilibrium. Okay, so the equation of the energy, so kita also can apply for quasi equilibrium state. Okay, quasi equilibrium meaning it's almost equilibrium but slowly the thing is changing. So kita tak boleh tengok dalam mata kasar. Okay, so that is what we call as a quasi equilibrium. So boundary work is actually boundary friction plus boundary atmosphere plus crank. Okay, so these are some of the derivation lah. Tapi kita tak tengok lah on particular things. Okay, so to calculate the boundary work, the process by which the system changes state must be known. Okay, kita selalunya akan tengok dari graf ni, pressure times volume. Okay, so pressure times volume. So this is there are two state 1 and state 2. Then you have a process part, then area under the curve. Area di bawah curve ni. So kalau you tengok gambar ni, so this is the first state, and when the system move, the piston move, the boundary is expanding. Work done on the boundary, and the boundary expand, and the changes from year to year is kawasan yang berlorek ni. Boleh tengok kan kawasan yang berlorek. So the area under the curve, so the boundary work is equal to the area under the process curve plotted on the pressure volume diagram. So you have the pressure volume diagram, and you are there from state 1 to state 2, and there's a boundary work done here, and the area under this curve we call it as a boundary work. Okay, boundary work. So the quasi equilibrium expansion process described is shown in the PV diagram. Yang ni adalah quasi equilibrium, sebab itu kita boleh calculate. We can calculate because it's moving slowly and we can see the differences. Okay, so as this piston move towards here, so kalau more work is done, boundary work is done on the piston, So this area under the curve akan jadi besar lah. Okay, sekarang kecil kan, dia akan jadi besar. Okay, so you will have more boundary work. Okay, so the pressure is the absolute pressure and always positive sebab yang ni graph above zero. So when the dV is increased, so dV adalah dekat sini. So kalau dV ni besar, so WB pun boundary work pun akan increase because it will become big. Okay, when dV decrease, so boundary work also decrease. Since the area under the different process curve on the PV diagram are different, the boundary work for each process will be different. The figure shows that each process gives a different value for the boundary work. So kalau you tengok dekat sini PV diagram, kita panggil as PV diagram ataupun PV graph. So pressure times volume. So from point 1 to point 2, so you can use a different part. So macam kalau you nak gerak dari Power ke Kanga, you boleh lalu various way. Boleh lalu Changlun Kuala Police Highway, so boleh lalu melalui Pekan Power, so boleh lalu other road, right? So for you to reach from point 1 to point 2, state 1 to state 2, you can take various part. Okay, so various part area under the curve dia berlainan. Sebab kenapa yang WA ni dia lagi banyak? Sebab area yang dia cover under the curve is bigger, more. Okay, so part C dia kurang, hanya 5. Sebab area yang di cover tu adalah sikit. Okay, so it depends on the part that you are taking. Okay, so there is another term called specific heat and changes in internal energy and enthalpy for ideal gas. Ada dua term, specific heat and also enthalpy. So yang ni actually kita dah belajar dalam chapter 1 and 2 lah. So awal-awal tadi, tapi I think I'm sure you all also can't remember. So I just review a bit. Okay, physics defines, boleh kalau baca dekat sini, physics defines that the amount of energy needed to raise the temperature of unit of mass of a substance 1 degree as the specific heat at constant volume CV for constant volume process, and the specific heat at a constant P for a constant pressure process. Panjang. So it's actually saying that specific heat is actually an amount of energy needed to raise 1 unit of temperature. Okay, 1 unit of temperature. And enthalpy selalunya kita panggil as H, is a sum of internal energy U and pressure volume. Product. Okay, so H adalah U plus PV. So U adalah internal energy and pressure volume product adalah PV. Pressure times with volume. Okay, so ini adalah kalau you campur dua-dua ni, you akan dapat the enthalpy value, which is H. But in thermodynamic, so selalunya kita akan dapatkan the enthalpy value from a thermodynamic table. So saya akan tunjukkan you thermodynamic table. So, how it is. Okay, so if you see thermodynamic table, I just want to review a bit. So kalau you tengok dekat thermodynamic table ni, so there are around 34 table lah, actually more. Tapi selalunya 34 table ni kita akan gunakan dalam thermodynamic. Okay, for you to find out macam constants lah, constants related, because all this thermodynamic table is generated by engineers. Okay, engineers who are dealing with thermodynamic, so that you will get a better understanding and you can use the values for your calculation. So kalau you tengok contoh dia, macam table A2, ideal gas specific heat, inilah specific heat for various common gases. Kalau apa yang the fluid that you are investigating is something related to ideal gas. Apa tu ideal gas? So, apa contoh ideal gas? Nitrogen. Okay, nitrogen, oxygen. Okay, so apa-apa gas yang is falling under the ideal gas category, so you boleh refer to table A2 to get the value. So kalau it is apa macam saturated water temperature table ataupun superheated water table, it's because the fluid can be available in different form. Kalau dia water pun dia boleh wujud dalam banyak keadaan. So dia boleh wujud dalam bentuk wap, dia boleh jadi ada dalam super cool solid ataupun water. So different. So kalau you tengok contoh thermodynamic table, saya tunjuk semacam ni. So table A1. Okay, so table 1 is actually molar mass, gas constant and critical point properties. So tengok kalau dekat sini, so ada few properties ataupun few substance given. Macam normally we will use for air. So molar mass adalah 28.97. So gas constant adalah 0.287. So you boleh refer dekat thermodynamic table ni and terus ambil the value, okay, for your calculation. Okay, so you tak perlu macam buat calculation from the scratch, because the calculation already done for you. Okay, macam oxygen, tengok 31.99, so molar mass, and the gas constant is 0.2598. So if the equation is using an oxygen, so you ambil lah value of oxygen dari sini. Okay, and you see this is table A2, ideal gas specific heat for various common gases. Okay, at 300 Kelvin. Okay, so for air, so boleh tengok gas constant adalah 0.287. So CP, the constant pressure adalah 1.005. Constant volume adalah 0.718. So these are the things that you can take directly. Ini saya bagi contoh lah. Okay, so contoh. So what is the gas constant for nitrogen? So kalau you tengok dekat table ni, gas constant for nitrogen berapa? 0. Gas constant 0.2968, kan? So what is the CP value for steam? So 1.8723. So if the question is dealing with steam, kalau dia cakap so in a closed control volume there's a steam, boleh refer terus dekat sini. So ambil value. So ini adalah contoh dia lah. Okay, so I just okay. So these are the things that are dealing. So even enthalpy pun ada dalam thermodynamic table lah, but different table. Tadi kita tengok table 1 and table 2. Maybe the enthalpy value you can get from table 5, table 6. So if it's related. Okay, so specific heats, so ada dua ni, CV dengan CP. Tadi kita tengok kan, ada CV value and CP value is given. So if there's a calculation needed, you boleh gunakan formula ni. Okay, for an ideal gas, the internal energy is U equals to UT for temperature. Using the definition of enthalpy, the equation of the state. So enthalpy tadi kita tengok H equals to U plus PV, and equation of state PV equals to RT. So kalau you gabungkan yang ni, so PV you gantikan dekat sini, you dapat H equals to U plus RT. So all these are some derivations. Okay, derivation I'm not really going through. Okay, so macam mana tadi you dapat CV? So CV is actually you getting from this formula. Okay, so yang ni adalah derivation lah. So I think just for your understanding. So it's not, it won't be tested. And some of all these are some of the formulas that you will use for your calculations. Okay, calculations. Tapi ini adalah sedikit derivation lah. So H equals to U plus PV. So if you want to find the changes, from here you boleh dapat lah. So DH equals to DU. So PV equals to RT. So dari page 11 you boleh dapat. So H equals to U plus RT. So you gantikan dengan sini. Then you replace it with the equation you get from page 12. So at the end you dapat the specific heat ratio K. So K equals to CP over CV. Okay. So tadi kalau you tengok dalam table tadi, so table ni, so you can get the R value, CP value, CV value and also the K value. K value adalah satu macam CP bagi dengan CV. So 1.005 bagi dengan 0.718 you dapat 1.4. So that is your K. So that is what you got from this slide. So K adalah CP over CV. So all the CP value and CV value you can get from your thermodynamic table. Okay, some typical process of closed system. Okay, dalam closed system boleh ada constant volume. Okay, constant volume. If the volume is L constant, so maksudnya dV equals to 0. So meaning there are no changes here, and the boundary work equation become, so WB become 0. Sebab yang ini dia berkaitan dengan volume. If there is no changes in the dV, so maksudnya tak ada perubahan dekat sini. Boleh nampak tak? Okay, so you tak nampak the point, the cursor, is it? Baru dapat. Okay, so if the volume is L constant for constant volume. So kalau dalam soalan dia bagi tahu itu adalah constant volume, so meaning you know the work done equals to 0. So work done boundary work done akan jadi kosong sebab tak ada perubahan dekat sini. Dia kena ada at least some opening so that you can calculate the area under the curve. Macam sini dia constant volume, so no opening, so no area under the curve. So if the working fluid is an ideal gas, what will happen to the temperature of the gas during the constant process? Yang ni you boleh ganti dekat sini lah. Okay, this is from the previous slide. So Q12, so meaning from point 1 to point 2 is changes in the internal energy. So internal energy adalah U2 minus U1. So U2 minus U1 adalah M U2 minus U1. So that is for this is for per kg. Yang ni untuk kg. Hanya untuk without per kg. Okay, for ideal gas you gantikan yang ni, gunakan formula ni. So the one that you have derived in page 12. So gantikan dekat sini, you akan dapat formula ni. Okay, so try to do this example. You cuba buat example ni. So when you do this example, you will get a better understanding of what we studied. So apa yang kita belajar sebelum ni is more on the derivation. So just for your understanding. Okay, so try to do this. Okay, so kalau you tengok dekat sini a rigid tank. Okay, a rigid tank maksudnya the volume is constant. The volume is not expanding or decreasing. A rigid tank contains air. So dia dah bagi tahu dekat sini the fluid is air at 500 kilopascal and 150 degrees Celsius. Okay, so there's a system. Air P1 equals to 500 kilopascal, T1 equals to 150 degrees. As a result of heat transfer to the surrounding. So meaning heat is transferred, Q out. The temperature and pressure inside the tank drop to 65 degrees Celsius and 400 kilopascal. So P2 equals to 400 kPa and T2 adalah 65 degrees. So determine the boundary work done during the process. So lukis dulu graf, lukis sketch dengan graf. Okay, sketch adalah ini. Okay, so I think you know how to draw this. Okay, from the equation, from the question you can draw this. Then the PV diagram. So from 500 to 400, dia cakap is a rigid tank. Okay, rigid tank. So 500 to 400. So that is on the pressure and temperature under 50 to 65. Okay, so determine the boundary work done during the process. Okay, this is expected since rigid tank has a constant volume. So rigid tank, so keyword dia adalah rigid tank. So kalau rigid tank is a constant volume, so kalau constant volume, so the boundary work done akan automatically jadi kosong. Okay, so soalan suruh cari determine the boundary work done during the process. So since is a constant volume, so the boundary work done adalah berapa? Boundary work done untuk constant volume. Boundary work done for constant volume. So boundary work done for constant volume adalah kosong. Okay, so kalau is a rigid tank, so that's why there is no boundary work done during the process because no area under the curve. No area under the curve. The boundary work done during the constant volume process is always 0. Okay, so that is one example. Okay, so try to do this example. So we will take 5. Okay, so try to do this example. Nanti kita discuss. Okay, so we will continue with this example. Okay, so a tank contains nitrogen at 27 degrees Celsius. The temperature rises to under 27 degrees Celsius by heat transfer to the system. Find the heat transfer in the ratio of the final pressure to the initial pressure. Okay, so the question is given like this. Okay, so I always encourage during the exam, so try to write like this. So first system, then you look case. So whatever related to system, it can be the sketch and the graph. So you look case, then property relation. So what are the things, what are the fluid involved, and which category. Kalau dia gas, so is it the ideal gas equation? So if it's ideal gas equation, then you can use ideal gas. If it's an ideal gas, then you can use ideal gas equation. Okay, so this question you can try with other variable specific in detail. Then you have a process. So what is the process? So tank are the rigid vessel, therefore it has a constant volume. So you write it specifically so that you know. You takkan buat silap lah. Then conservation of mass. So M2 equals to M1 because it's a constant volume, no mass is entering or leaving the system. Because it's a constant volume. Buat macam ni lah. So in this case, so it's a nitrogen in a tank. So nitrogen in a tank. So you have a system, you have a tank, then you have a boundary, a system boundary, and you have a nitrogen inside. And the graph is so between two temperature. This thing I need to tell. So for your PV curve, PV graph, pressure times volume. So dia ada banyak curve. So different temperature, different curve. So macam ni dia ada dua temperature, 27 degrees Celsius dengan under 27 degrees, under 27 degree Celsius. So each Celsius dia ada different curve. Sebab tu dekat sini dia ada dua curve. So curve pertama adalah 27 degree Celsius and curve kedua adalah under 27 degree Celsius. So temperature from 27 increase to under 27. Okay, sebab tu arrow dia ke atas. Okay, so N is a constant volume. So dia hanya satu garis lurus. Dia tak ada perubahan sebab volume tak berubah. Okay, so dia hanya satu garis. Okay, so that's how you draw the system. Then the property relation. So nitrogen is an ideal gas. Then you can use a ideal gas equation. PV equals to RT. Okay, boleh gunakan yang tu. Then the process is a process. Tanks are rigid vessel. Therefore the process is a constant volume. Yang ni kita dah tahu lah. Okay, the conservation of mass M2 equals to M1. Sebab mass entering and mass going out is the same. So actually no mass coming in lah. So meaning the mass inside the tank is always the same. Okay, so you combine ideal gas equation of state. So PV equals to RT. So you akan dapat macam ni lah. So this is one adalah initial and two adalah the final state. Okay, since R is the particular gas constant, the process is a constant volume. So R you dah buang dah, and volume pun sama. So V2 equals to V1. So V2 dengan V1 you cancel, you dapat P2 over T2 equals to P1 over T1. So you rearrange, you dapat macam ni. You just kena cross lah. You dapat P2 over P1 equals to T2 over T1. So T2 dengan T1 dia dah diberi dalam soalan. So 127 plus 273 sebab dia dalam Kelvin. So 27 plus 273 dalam Kelvin. So you dapat the ratio adalah 1.333. So kalau you tengok dekat sini, soalan disuruh cari the ratio of final pressure to initial pressure. So final pressure to initial pressure adalah 1.333. So that is the first part. Okay, then the second part, conservation of energy. So thermodynamic first law of closed system. So ini adalah formula yang you tahu, E in minus E out equals to the changes of the energy. So Q net minus W net equals to changes of energy. Okay, for nitrogen undergoing a constant volume process where no changes in the volume, so dV sama dengan kosong, the net work is the work other. Okay, sebab yang ni adalah formula untuk the net work done. Okay, net work done adalah other work done plus boundary work done. Okay, so boundary work done since constant volume kosong, so other work done pun kosong. Sebab dia no other work is done on the system. Okay, so you gantikan dalam formula dalam page 12, you boleh refer balik page 12. So U2 minus U1 equals to CV T2 minus T1. So you gantikan dalam ni. So Q net dalam ni, dalam soalan dia tak bagi tahu the volume, the mass. So you just bagikan dengan mass. Okay, since the question is not given, the mass is not given, so you just cari E transfer per unit mass. Q net equals to Q net per M. So these are the thing. So M dibuang, so M you cancel, M dengan M you cancel, you dapat finally CV equals to T2 minus T1. So CV nak cari dekat mana? So cari dari table tadi, CV. So specific heat at constant volume for nitrogen. So I dah carikan untuk you lah, 0.743. So kalau you nak cari nitrogen, CV for nitrogen adalah 0.743. Okay, so that's how you get your value. Okay, so you gantikan dekat sini, CV you dah dapat T2 minus T1 127 minus 27. So you dapat at the end the heat transfer per unit mass adalah 74.3. Okay, so that's one thing. Okay, another example, the specific internal energy of a fluid is increased from 120 kilojoule per kg to 180 kilojoule per kg during a constant volume process. Dekat sini pun dia dah bagi tahu constant volume. Okay, so you automatically you know that the boundary work done is 0. Okay, determine the amount of heat energy required to bring about this increase for 2 kg. So you cari per kg dulu, then you kali dengan 2. So kalau dia bagi you mass lah. Okay, so Q net minus W net equals to U2 minus U1. So that's the internal energy. For constant volume process, work equals to 0. So W net jadi kosong lah. So Q equals to U2 minus U1. So U2 adalah under 80 minus under 20. So Q is 60. So Q is 60 for per kg. Because dekat sini dia bagi per kg. Okay, per kg. So for 2 kg you kalikan dengan 2. So 60 times with 2 kg. So you dapat under 20 kilojoule. So under 20 kilojoule of heat energy will be required. So this is another example. Okay, so earlier we see for constant volume. Sekarang kita tengok untuk constant pressure. Sebab dia dekat PV graph dia ada P and also V. Tadi kita jadikan V constant. Sekarang kita jadikan P constant. Okay, meaning the pressure is constant. So kalau you tengok dekat sini, this is your PV graph. PV graph, volume ada berubah. Volume ada berubah from 1 to 2, tapi pressure the same. Pressure the same. Sebab tu dia flat. Dia tak ada perubahan. Okay, so if the pressure is L constant, the boundary work equation become so kalau in constant pressure case, boundary work done tak jadi kosong dah. Sebab dia area under the curve kan. You boleh cari area under the curve ni. Okay, so so you kena gunakan formula ni, M P V2 minus V1. So V2 minus V1. So you boleh carilah dekat ni. So you gantikan dekat heat transfer equation, at the end you akan dapat equation ni. So U plus PV minus U1 plus PV1. So U plus PV is actually the enthalpy or the H. So H, so this is actually H2 minus H1. Sebab U plus PV adalah H. Okay, so H adalah U plus PV. So you akan dapat H2 minus H1 equals to M H2 minus H1. So for ideal gas, you akan dapat, you boleh gunakan formula ni. So from the derivation, so this you get from this thing, H2 minus H1 equals to Cp T2 minus T1. So at the end you akan dapat yang ni lah. So I think this coming from page 12. So you boleh refer balik lah. Sebab itu I tunjuk dekat sini, apa-apa yang saya letak arrow, so meaning, so you boleh refer dekat the previous slide. Okay, this is actually from where you get this. Okay, so you need to understand that this slide is not belongs to me. So this from the previous lecturer. So memang dia sediakan slide macam tu. So all these notes is something that I added for your understanding. Okay, so dari mana you dapat? Okay, so you dapat dari formula ni. Okay, so you see this, air undergoes a constant pressure cooling process. Okay, so dalam soalan dibagi tahu constant pressure ataupun constant volume in which the temperature decreases by 100 degrees Celsius. Okay, so dekat sini dia when you are having a constant pressure, so the cooling process, so you lukis lah system. So you have air and you have a boundary. So ada boundary work done, and this is your PV graph, and the property is air, so it's an ideal gas. PV equals to RT, and the process is constant pressure. Okay, so process tu you tulislah constant pressure ataupun constant volume. And the work calculation neglecting the other work, so hanya ada so since this is a closed system, no other work done. So no other work done on the system. Okay, so only have the boundary work done. Okay, so W net, so 0 plus boundary work done. Okay, so ini dapat dari PV equals to RT, and you dapat formula ni, M equals to R T2 minus T1 per unit mass work done. So work net equals to per unit M. So M ni cancel, so you tinggal R T2 minus T1. So yang ni you dapatkan dari Ini actually dah diberi dekat sini, tapi you boleh dapat dari the table tadi. Okay, because it's ideal gas. So you refer to the table of ideal gas. So for air is 0.287. So kalau you tengok dekat the table paling atas, so the gas constant is 0.287. So different gas you boleh refer dekat sini. Okay, so 0.287. So T2 minus T1, you boleh tengok dekat sini, decrease by 100. So meaning the temperature difference is decrease, so minus. So terus letak dekat sini. So tak perlu ada apa T2 apa T1 apa. So temperature difference meaning, so T2 minus T1 dah. Okay, so just you need to put negative because the temperature decreases. So minus 100. So you dapat the work done is minus 28. So earlier I say if minus, the work is done by the system, but the work is done by the surrounding. So by itu dekat sini ditulis the work done on the surrounding is 28.7. So yang ini actually work done by the system lah. Selalunya I takkan tulis based on surrounding. I will write based on the system. So kalau tak you akan confused. So always tulis kalau ada negatif dekat sini. So negative 28.7 meaning the system is doing work. So yang ni you boleh tulis lah the work done by the system, bukan done on the surrounding. So tulis the work done by the system. Boleh buat correction lah kalau you ada nota physical. So the work done by the system is 28.7 since W net is negative. Okay, so these are some of the universal gas constant that you can get. So kalau dalam exam ada soalan yang berkaitan dengan yang thermodynamic table, saya akan bagi dalam appendix. So you just need to open at your appendix to refer. Okay, jangan bawa nota kecil dalam exam. Jangan bawa tuyul. Okay. Okay, so one more example, the final example. Okay, so 2.25 kg of fluid is having the volume of 0.1 meter cube, is a cylinder of a constant pressure of 7 bar. So dia dah bagi tahu constant pressure, the pressure is 7 bar. Heat energy is supplied to the fluid until the volume becomes 0.2 meter cube. Dari 0.1 jadi 0.2. Okay, if the initial and final specific enthalpies, so enthalpy maksudnya H. Okay, so final enthalpy adalah H2, initial enthalpy adalah H1. Okay, so dia dah bagi dah value enthalpy dekat sini 210 and 280. So initial adalah 210, final adalah 280. So they asked to determine the quantity of heat energy supplied. Okay, Q, disuruh cari Q. Okay, so heat energy supply is equals to change in enthalpy of the fluid. So Q equals to H2 minus H1. So you boleh cari dekat sini lah. So this is actually the formula. So M H2 minus H1. So mass adalah 2.25, H2 adalah 280 minus 210. So the heat energy supplied to the system is 157.5 kilojoule. Okay, so that is how you can calculate. So boleh gunakan formula ini. And for the second thing, apa yang disuruh cari, the changes in internal energy of the fluid. Okay, maksudnya disuruh cari U2 minus U1 lah. U2 minus U1. Okay, for constant pressure process, the boundary work is P V2 minus V1. So pressure is 7 bar tadi. 7 bar you convert to Pascal. 7 times 10 to power of 5. So kalau you nak convert bar ke Pascal, so you kena kalikan dia dengan 10 to power 5. So V2 minus V1 adalah 0.2 minus 0.1. Yang ni diberi dalam soalan. So at the end, the boundary work done is 7 times 10 to power 4, which is 70 kilojoule. Okay, so ini adalah boundary work done. So applying in the non-flow energy equation, Q net minus W net equals to U2 minus U1. So ini adalah general form. So dekat sini, so W net adalah okay, so yang ni you rearrange lah. So you rearrange, so U2 minus U1. So Q net tadi berapa? So 157.5. So work done, the only work done on the system is boundary work done. So 157.5 minus dengan 70. So the change in internal energy of the fluid is 87.5 kilojoule. Okay, so end of chapter 7 part 1. So you boleh refer balik dekat this recording and also the slide for you to understand. So minggu ni saya akan bagi puzzle video for chapter 7 part 2. Okay, chapter 7 part 2, so that kita akan buat discussion next week. Okay, for next week kita akan ada kelas lah macam biasa on Wednesday morning. Okay, so any question? Ada soalan? Okay, so that's all. Okay, saya akan panggil nama. Lutfi Ladi? Ada Lutfi Ladi? Tak ada. Mo Izin? Mo ada? Ada. Muhammad Faiz? Muhammad Faiz ada? Tak ada. Muhammad Faris Faizal Rizal ada? Muhammad Faris ada? Muhammad Faris Kamarudi ada? Muhammad Firdaus Muhammad Farid? Muhammad Hakim Hakimi? Hakim Hakimi ada? Muhammad Aziz Aikal? Aziz Aikal ada? Ada. Khairul Azhar? Ada. Muhammad Nabil? Zahirul Hakim? Nur Fakira? Nur Hafizatul? Hafizatul Akmal? Syarul Azlan? Tan Yu Chen? Umar Razi? Unko Arman Shah? Wan Nur Kamarina? Ada. Zarik Iskandar? Tak ada. Okey.